Our next speaker and the first one for the day here on the orange stage is Felienne Hermans. She's the author of the upcoming book, The Programmer's Brain, and the creator of the Hindi programming language. Today, we are going to learn from her how to read complex code. Please give a warm welcome to Felienne. Felienne, the stage is yours. Have a lot of fun.
Good afternoon, everyone, or good morning, depending on where you are. My name is Felienne Hermans, and indeed today we're going to talk about how to read code. But before I will dive into that, I will take you a little bit back into my own personal history to make you understand how I came to research the topic of reading code. So we have to go back to the year 2013, back in time. And in that year, I had just finished my PhD in software engineering, and then I started to teach programming to children. So there's a group of children, 10, 11, 12-year-old children, and they wanted to learn programming. And through networking, they came to me and they asked me if I wanted to do it. And I thought, well, I can teach you children. Secretly, I thought, how hard can it be? They are children. So this cannot really be hard, even though I didn't know that much about teaching. I just had a degree in programming and software engineering, so I didn't know that much about teaching. But again, I thought it will not be really hard. And then what happened is that subconsciously, I started to think back of how I learned programming when I was a kid. It wasn't that I explicitly thought, oh, let's teach these children how I learned, but you sort of remember this history and bring it with you. So this is me when I was about 10 years old, sitting behind my dad's big computer, teaching myself programming. And in this story, that might be familiar to you if you're sort of my age, there wasn't someone teaching me programming. I wasn't in a programming lesson because this was end of the 80s, early 90s. There weren't so many adults that could do programming. So I only learned from a book. I had this book specifically, Basic Computer Games. And this book, if you would open it, it wasn't very much a book that explained you how to do something. If you would open it, then it's just printed out basic code was in the book. And maybe you hear from my accent that I'm not English or American. So English isn't my native language. It's Dutch. So I didn't even know what most of these words meant. I just mindlessly typed them into the computer. And then after a while, somehow I knew programming. So there isn't a programming teacher here in my history. That meant that I didn't really know what a programming lesson was, what it looked like. And that isn't just me. Many professionals out there today went through the same story, so they don't really know how to shape a programming lesson. So they just let kids sort of do the same thing, right? Just give them some books and let them explore. And that's very much what I did too. I bought some programming books and I gave them to the kids in the programming club and let them sort of do the same thing. Basically, the underlying assumption was somehow that the compiler is a teacher, right? That if there's an error, then the computer will tell you. You still see that vibe of self-teaching very much present in programming books for kids that you can buy today. So we'll look at a few examples together of what we tell children that are learning programming about what learning programming and what programming means. The books will be in Dutch, but there's an English translation underneath for most of you, I guess, that don't know Dutch. So what it says here is the best part of programming is finding mistakes. It's kind of specific, right? I don't like finding mistakes. Half of the time, I am the person that put in the mistake. So maybe fixing mistakes. But the type of person that says that finding mistakes is the most fun in programming, that is someone that has pushed through the pain of learning and then came out on the other side. Here it says, you will fail often, and it will be frustrating, which of course is somehow true, but also it's a weird thing to say because learning anything is hard. Learning soccer is hard, or learning to bike or play the piano. So specifically putting this in a book for kids also is very telling about our community. If you buy a book, Soccer for Kids, then it will not say, learning to play soccer is hard and it will be frustrating, even though that too is true. It will probably say stuff like, oh, if you really do your best, then you too can be Ronaldo or Rapinoe or something like this, encouraging and not sort of discouraging. Never be afraid to mess around and experiment. So this messing around, experimenting, trying out for yourself, even though it's frustrating, that's part of the fun, is very much part of the culture that we tell each other. And clearly, this isn't just true for kids. This is something we also, as professionals, keep telling each other. Unsurprisingly, especially to people that may have also already taught children programming or anything else, it didn't really work so well. So I was really surprised because I thought, well, this is the way I learned. So why isn't this working for kids as well? I sort of got frustrated that they weren't really learning and they weren't so effective at learning from just trying out stuff. And again, a reminder at that point, it's a bit better now, but at that point, I really didn't know that much about teaching, but I got really excited to learn about teaching because these kids, as I mentioned, this was a community center and kids were coming in voluntarily on their free Saturday afternoon to learn programming. And then they weren't learning and they weren't having fun either. So I couldn't tell myself, like somehow I was telling this to myself with students, right? Oh, maybe they're not motivated. Maybe they're not so smart. But these kids voluntarily come to spend their Saturday afternoon learning for me. And then if they're not learning, it was clear to me that was on me, that I needed to do a better job there. So what I did is I started to really, really dive into how people learn how do people learn anything? And it's sort of sad that computer science programs don't really teach you any of that, right? I had a PhD in software engineering and I had no course on learning. And I had no course on like how to use my brain effectively. I had no, sorry about that. I had no course on how to use my brain, how to learn anything, which was really sort of sad because I had, I don't know, 5 courses about how to use compilers and how to use grammars, but no course at all about how to use my brain, how to do thinking. So what I learned from studying thinking in books later on is that we don't really teach reading code. So I had no clue also how to read code. There weren't courses about how to read code either. And if you compare that to how we teach natural language or how we teach math, then there is lots and lots of deliberate attention to how to process something. So just to give you a scenario from the club, a kid has made this program a few weeks ago, right? And then they come back to this program and they don't really remember what it says. So they say, hey, teacher, what does this code do? And then I would say, what do you think it does? Right? This is very much this never be afraid to mess around and experiment vibe. And I think if there are people in the audience that have tried to teach programming to kids, this is something that's maybe familiar to you, where you're very reluctant to give the answer because you want them to figure out the answer for themselves, because this is this culture that we propagate. And I've seen also in onboarding in companies that this is also a pattern if you're onboarding a junior developer. Then a junior developer might ask you, hey, where in the code does such and such happen? And rather than just telling them where it is, people are very interested in saying, oh, let me show you, and then it's more or less here, or this is how it goes. Reluctant to give answers because you think in teaching sometimes it might spoil the fun, but also that they're not learning effectively if they've been told the answer rather than found the answers themselves, which isn't very true, by the way. So kids got really frustrated, right? So I said, what do you think? And then the kid's just like, I don't know. This is why I'm asking you. So it really wasn't a helpful strategy. And even this program, you might know this is a programming language called Scratch. It's not even an easy question how to figure out what this does, right? At least in code, you could have this natural reading order from top to bottom somehow. But here, this is event-based. So how would you even figure out what this does? I don't even know what a good strategy is. If you compare that to how we treat children if they're learning natural language, you can see it is really, really different. So if you have a kid that's learning and they say, hey, mommy, what does this word say? Then you're not going to say, well, what do you think, right? You're going to say, look at this first letter. Is that something you recognize? You sort of cut the problem into little pieces. And then if they don't know the whole problem, you give them a little piece. And then if they don't know the little piece, if you say, do you know the first letter? And the kid says, I don't know. You'll just tell them, right? You'll just read the word for them. You're not going to say, oh, well, maybe try again to read it if they have no strategy of reading. And that's not just true for natural language, it's also true for other, like more hobby occupations like music or sports. If you want your kids to play the guitar, then also you're not going to say, hey, here's a guitar. just try it out a bit, right? You'll tell them, or a teacher will tell them, what the individual parts are. But in programming, we very much adopted this belief that trying out and experimenting is the way, the only way, the best way to gain knowledge. So we don't really teach reading code. That's the first thing I took away from my explorations into reading code. A second thing that I took away is that we don't really practice reading code. And now I'm more moving my attention away from teaching towards also professionals. If you're a professional programmer, when do you practice reading code? Like never. There's research that shows that professional programmers spend about 60% of their days reading code, comprehending code. So that's a really big chunk of your day. But then the stories we tell each other is that if you want to get better at programming, you should do more programming, right? You should have this Saturday afternoon hobby open source project, or you should go to a code kata or code club where you practice writing code. Always, if we talk about advancing in code, we talk about writing code. Never be afraid to mess around and experiment. This is what we believe, that from messing around with code, you're going to get better at writing code. And you might know that there's this advent of code always in December, right? Where everyone sort of comes together to practice. That also, again, shows we're all writing code. There's not something like an advent of reading code. It's all production. Everything is production. And this is so much our culture. And again, if you compare that to other fields, then it's sort of weird. If you want to write a novel, then you have already read many, many novels, right? You have your own favorite authors. No one will say if you want to write a novel, you just start writing without reading anything. It's a very particular culture once you start reflecting upon it, which I did extensively. So the third thing that I took away from trying to understand how people learn anything that isn't code is we don't really have theories for reading code. Like I said with the Scratch program, like what is a good strategy to even read that? How do you do that? We don't really know. We don't really know what happens in your brain when you read code. There's a bunch of work along these lines. There's this fantastic professor in Germany called Janet Zygmunt. She puts programmers into an fMRI scanner to try to figure out what happens in our brains, which is really, really cool. But by and large, there's still a lot that we can learn. But luckily, we do know a lot about what happens in your brain if you read normal text, natural language, if you process information. So in the remainder of this talk, I want to take you through what actually happens in your brain if you read code and how we can use that knowledge to advance understanding how to read code better. So the basics that you have to know is that if information comes into your brain, it first enters your short-term memory. And your short-term memory is very, very, very small. We already have known this since the 1950s. Your short-term memory only fits between 5 and 9 items. So it's really, really tiny. You cannot think of more things than 9 at the same time. We can do a little experiment because this is a bit abstract, of course. Let's do a little experiment in which you have to try to remember something. And we can see that remembering more than 9 things is really very hard. So I'll show you a sentence very briefly, and it's your goal to remember the sentence. So you have to pay attention and try to really imagine that you have to read the sentence aloud to me or write it on a piece of paper, like this is an exam. Here we go. Are you ready? So now you're like, wow, this is impossible. This is unfair. I can never do that. You see how bad your short-term memory is? I show you this small sentence and it's impossible to remember because you really can't register. But I only showed you part of the puzzle because you can see where this is going maybe. Your short-term memory, once it has remembered everything, it starts processing what you've just seen. And that processing is done in your working memory. And your working memory works together with your long-term memory. So if you see something, immediately your working memory is activated. It's like, oh, what do I know about this thing that I'm seeing? And relevant information from your long-term memory will be given to your working memory as well. So we'll do another sentence, and you can see that it's actually possible to do such a sentence, equally long in an equally short amount of time. So we'll do another one. Here we go. Don't blink because you might miss it. So that was easier, right? It was still hard, but it was somewhat easier because immediately your long-term memory was ready to help. Your long-term memory was like, these are letters. I know these letters, A, M, B, K, R. So it was giving you relevant information. But still it was hard because it was all separate pieces. So we'll do one more and you see how strong, how impactful your long-term memory can be on your working memory. Here we'll do another one. There we go. So this you could remember, right? You see how much difference prior knowledge makes on processing. Because this was cat loves cake. And this is your long-term memory helping you, right? Your long-term memory is, oh, I know these letters. Oh, I know this thing. This is a cat. Immediately. And then it's loves, and then it's cake. So you don't have to remember all the individual elements. Your long-term memory just gives you these chunks. It's what this is called, these individual pieces. And then instead of all these separate letters, this is just three things. It's just cat, loves, and cake. And those three things easily fit in the limit of your short-term memory because it's way less than 9. Knowing this, knowing these three different memory systems and knowing the strength of prior knowledge on processing, we can now deeper understand what happens in your brain when you read code. And for that, we're going to explore 3 different programs that interact with different memory systems in a different way. So first, we will look at this APL program. So APL, this is an abbreviation of A programming language, is a vector-based programming language that I am assuming most of you aren't familiar with. So if you have to tell me what this program does, if you have to read it, then this thing is the problem, right? This letter T is the issue. You probably don't know what this thing does. So this is a long-term memory issue. You look at the code and your long-term memory says, that's the letter T. The end. It's not really helping anything more. That's really different from this type of confusion. So if you look at this program that's in Python, imagine you're not a very experienced Python programmer, then this is going to sort of overload your short-term memory. It's going to go customer names, C dot first name for C in customers if C dot age bigger than 50. This is many elements. And if you're an experienced Python programmer, you could probably quickly see that this is a list comprehension. But if this whole structure is new to you, like the weird letters and the weird words that I showed you before, these individual items will overload your short-term memory. So you see here, if you're an experienced programmer, this is cat loves cake. If you're not an experienced Python programmer, this is abracadabra, and it will overload your short-term memory. So this is a short-term potential, short-term memory issue. You see, that's really different from the first confusion that we had. And here's yet another form of confusion. This is a basic program. Here, your long-term memory, of course, also plays a role because you have to know what is let and for and int. Your short-term memory also plays a role because you sort of have to remember what's going on. But there's a third issue here. This is a working memory issue because you're like, oh, what exactly is going on? You sort of want to step through the program with a debugger, like, oh, imagine n is 7. Then, okay, so if n is 7, then n2 is 3, then b string is 1. It's too hard to process at once for your brain, whereas the list comprehension and the APL encode, you could immediately process it as long as you recognized it. Here you recognize all the elements, but you cannot at once process this without sort of having this need of taking your finger or taking a pencil and starting to make some notes. So this is a working memory issue. So very often when I hear people say, oh, reading code is so hard, it would be easier to just throw away this library or not use it and make my own. It's not true that reading is necessarily hard. And remember again my 3 sentences. The first one was excruciatingly hard to read, but then the final one was sort of okay. So in the same sense, you can get better at reading code just like you got better at reading natural language. So one of the things I think that has really helped me be a better reader of code is that you have to understand why it's hard. So these 3 different confusions each have their own different solutions. So if you just think, oh, this is really confusing, I don't know what to do, let's throw this away and re-implement. Yeah, if you don't have a strategy, that's sort of legit. But if you can recognize your own confusion, you can also solve your own confusion. For example, in this program, the APL program, your issue is in your long-term memory. You just don't know what this symbol is. So what you can do, and this is very much sort of against the grain of the culture of programming, is that you can actually practice syntax elements. So if you would want to learn APL, then you can make what's called flashcards. So flashcards are little paper cards that on one side, oh, this doesn't work with my auto background. So on one side, you write the syntax element, and on the other side, you write the definition. And then you can simply use these cards to practice. You put them on a stack on your desk and you take one side and you're like, oh, do I know what this thing is? The T is not a T, actually, it's called encode. You can just practice. And you can also make these syntax cards for, you put for loop on one side, and on the other side, you put the definition of a for loop in Python. And you can use it also for API calls that you commonly use. If you already know Java and you want to learn Python, you can put Java on one side, you put Python on the other side, you put the stack of cards on your desk, and every day you practice a little bit. This isn't what we tell each other that works, right? Because we tell each other, oh, you can just Google syntax. This is a lie. Of course, you can Google syntax, but remember the 3 sentences. And remember how spectacularly easy it was to read when you have some prior knowledge. So if you practice syntax, you will be a better code reader, because if with every element you have to look it up or think really heavily, your brain gets really, really full. So syntax, flashcards is what this technique of cards is called. It's a really good way to strengthen your long-term memory, and then it can be helpful when reading code. That's a really different problem from this problem, right? Here, your problem isn't necessarily your long-term memory. So you know what the brackets are. That means a list in many programming languages. So that's sort of familiar if you don't know Python. You probably know that the dot is finding a field on something. But if you don't know this specific language construct, it's very Pythonic. As I said, it's a list comprehension. Then it might take you time to figure out what's going on here. So what you can do is you can actually rewrite this code, because what this actually does, if you're not familiar with it, is this is what it does. So it creates a new list, customer names. It loops over an existing second list called customers. And then every time if the age is over 50, you append the first name. If you aren't familiar with the list comprehension, the top version, the second version will be way easier for you to process. Of course, you can do it in the first form, but then it takes you energy. So if you make code more familiar, closer to your own prior knowledge, that means it is less chunks, it is less elements in your short-term memory. And this technique is what I call a cognitive refactoring. So it's a refactoring because the external behavior of the code stays the same. But it's not really a refactoring because it's not really making the code better. Some people might be now yelling at their screens at home saying, oh no, you're making the code worse because list comprehensions are shorter and more functional. That is true in general, but that isn't true for the reader that doesn't know list comprehensions that well. So this is a cognitive refactoring that you can use to bring the code closer to your own prior knowledge so that it's easier to understand. And then later on, you can put it back, right? So just temporarily, if you understood the code, you can roll it back. Then there's the third form of confusion. If your working memory is really, really overloaded, then you can aid your working memory. You can, for example, make something like a state table where you write down all the individual values of all the variables in the program. So you can say in the initialization phase, let's take 7 as an example, then N2 is 7, B string is the empty string, and then we step through the list. Okay, what happens in the first iteration? Okay, so we step from 7 to 0, we divide by 2. Step by step, you're trying to understand what is happening so that it doesn't all have to happen in your brain. You can offload a little bit of your brain power to paper. Of course, it doesn't have to be actual physical paper. This can also be done in a debugger, or it can be done in other automated ways. But at least here you have to realize this is hard because I have to do heavy thinking. My tiny brain, here also, you just have 9 processing elements in your working memory because it's very related to your short-term memory. So you have to understand my brain is too tiny to process this. So I have to offload my processing power in a buffer that's not in my brain. To summarize, because I want to start wrapping it up because I really want to engage with you as well to do some Q&A. To wrap it up, the most important takeaway of this talk is that if you understand why code is confusing to you, you will be a better programmer. Because if you're just like, oh, I'm stuck, help, this is hard, such and such, it's such a terrible programmer for writing this terrible code, that's just not helpful. So if you know why code is confusing to you, you can actively get better at it by strengthening your long-term memory, supporting your working memory, or aiding your short-term memory with a cognitive refactoring. So that's it. If you want to know more, there's a bunch of places that you can check out. Firstly, as was introduced in the beginning of the talk, I wrote a book on all of this called The Programmer's Brain. It is now already out as an ebook, so you can already buy it at Manning. I will have a link at the end of the slides. And the print book is set to come out in September. You can already pre-order it at the publisher. You can also pre-order it at Amazon. But if you really want to read it like today, you can buy the ebook and dive right into it this weekend. What I also found to be very, very valuable is to do deliberate code reading practices. So I've been working with many companies where we started to do code reading clubs. So you get together with a bunch of colleagues, weekly, bi-weekly, or monthly. You grab some code from your own code base or just randomly stuff from GitHub, and you just read it together. And you talk about it, like, why is this confusing? What do you think is like the most important part of this code? Why do you think this code is the way it is? And I found that this is really, really valuable. This started out as a really weird idea where I'm like, oh, let's try this. And now there are many companies that have these code reading clubs regularly, and people really seem to benefit from it. I have a link to free code reading club resources also at the end of the talk. So that's it. Let me do a brief summary of the talk. So if you missed it, because I know, I talk a bit quickly and it's end of day for many people, I'll just summarize everything in like 1 minute, and then we'll dive into the Q&A straight away. So we talked in this talk about how to read code. We have this culture in programming where we keep telling each other that if you want to get better at programming, you have to do more programming, which probably isn't true. If you know what happens in your brain, these 3 different memory systems, then you can understand that different confusions are present when reading code, and they each have their own different solutions. Practicing syntax, cognitive refactoring, and supporting the working memory. If you want to know more about my work, I'm on Twitter under @Felienne. If you know my first name, I'm very easy to find. You can also check out my website where I talk about my own research about code comprehension and the research of others as well. If you want to know more about my book or buy my book straight away, you can go to felienne.com/book. And if you want to know more about code reading clubs, we have free resources that you can find under felienne.com/club. Maybe you're wondering, so what happened to the kids that you are failing in the club? So I made a programming language actually for kids. So my exploration about how people learn ended up one for one in the book, but also everything I learned also ended up in a programming language for kids that I made. So if you're currently teaching children, I would be honored if you would just check it out. My programming language is called Hedy, and you can go to felienne.com/Hedy to check it out. It has been translated into various natural languages, including English and also Hungarian. So if you're interested in that, definitely check it out. It is free and open source. And if you like listening to me and you're like, oh, I would love to listen to that lady for hours and hours and hours more while I commute or bike or do the dishes, that's possible because I'm one of the hosts of the IEEE podcast, Software Engineering Radio. We're on iTunes and Spotify with weekly episodes about how to become a better software engineer. And then before we go to the Q&A, I will answer one question because people always ask me, how do you make those slides? Do you draw them by hand? And the answer is yes. On my iPad with an app called GoodNotes. So I have this whole library of all these cartoon images. That's how I make my slides. So that question doesn't have to be asked, but I'm sure there are many other interesting questions in the Q&A that we can hop over. Straight away.
Thank you, Felienne, for this fantastic talk. And yeah, I suggest we go to questions because there are quite a few. So, the first question comes from Anonymous. It's a very popular one. Do you think comments make the code easier to read or harder because it separates the code?
That's a great question. So I have a whole chapter in my book about comments and variable names and how they help or hinder. Mostly comments help. So they are useful. So we know that if people read code, then they do focus on comments. And you can check that with eye tracker studies. So you know that this is something that people look at. Of course, there's the risk that people always say, yes, but comments can go outdated. And yeah, that's true, but that doesn't mean that they don't work. That's like the tires on your car. You can say, oh, tires don't work because I have to change them every 5 years. Tires work fine. You have to do maintenance on them. This is the same is true for comments. So I think just discarding comments because they have the risk of getting outdated it's just because I think writing comments is harder than writing code, less fun. I think people are sort of looking for an excuse not to write it. But yeah, research shows that this is very much something that people look at and something that people use while trying to make sense of the code. So by and large, they are helpful.
Thank you for the answer. Next question also comes from Anonymous. Do you have any recommended code to read from open source?
That's a lovely question. So I thought about that a lot when we started the Code Reading Club, and my answer now, after doing this for a year and a half, is it really doesn't matter. It doesn't matter what you pick. You can just go to GitHub and pick the first project from Java with most stars or something. When practicing, it really doesn't matter that much. And this is hard to believe if you haven't done it, because I was also very much worried about, okay, but what will we read? But the interesting thing with code is there's always stuff that you recognize, and there's always stuff that you are confused about. Even if you look at your own code base that you maintain by yourself, there will still be parts of code where you're like, what did I do again? So any code is a good mix of what you already know and what's confusing. And what we did find is that it really matters what your goal is. So if your goal is learning Rust, then take Rust code, and then maybe also take easy Rust code. If your goal is to really become an expert reader in Java, yeah, then it makes sense to take a little bit more complicated code in Java. So you have to think about what is my goal here. But in general, it doesn't really matter. You can just start. We have also, by the way, if you do want to check it out, we have some code reading clubs on the website prepared, where we have an agenda and also a link to codes you could use. So if you don't want to decide, you can use our example.
All right, thank you. It's an awesome answer. Next question. Do you think these methods are also good for adults who want to get started with programming?
That's also a great question. So initially also I thought, nah, you need to know a little bit. But there's a few boot camps that teach programming to adults, so adults coming from other professions into programming. And they've been experimenting with putting reading earlier and earlier and earlier in their curriculum, and they find it really works well. Because reading also, it takes away some of the fluff. Like you don't have to know how to run code to read code. So you don't have to mess with an IDE. If there's one semicolon in the wrong place, you could still read the code, but you couldn't compile it and run it and run tests. So I initially thought this is something for a bit more advanced programmers, but the more I'm trying it and the more other people are trying it as well, I think it could be done, maybe it should be done before writing.
All right. Okay, we have another very upvoted question from Peter. Do you have exercises that could help us test/train ourselves? Also, these ideas could be used great as an interview test to see how well the interviewee thinks. Do you agree with that?
Yes, definitely. So the final chapter on my book is about onboarding. And I know onboarding and interviewing isn't the exact same thing, but it's definitely about activities you can do with newcomers. So I definitely think that if you give someone a snippet of code and you ask them, what does this do? You can learn a lot about how that person thinks, how that person approaches it. In these tricky coding interviews, right? It's like, oh, you just have to reverse a linked list or something, or flatten a binary tree. Then it's maybe a bit more hit and miss. Like if someone knows it because they practiced it before, then they know it. And if they don't know it, they don't know it. I think if you focus more on process in general, not even necessarily only with reading, but if you focus more on process, you will see more how people approach it. Also, are they willing to admit they were wrong? Are they willing to let go of an hypothesis that now has clearly been disproven? Like first they think, this is, grabbing something from there. So, no, it's an internal variable or something. So do you see them change their mind? Are they open to feedback? Are they open to ideas? If you say like, but maybe you should also read that function, like do they do it or do they stick with their own plan? I think there's a lot to be learned from reading practices.
All right, thank you for that answer. Next question comes from Christiane. Do you think group code reviews could also help with this.
What's the question? Group code reviews or good code reviews?
Group, as in multiple people.
Yes, yeah, in general, I think. Like the code reading clubs we've been doing with groups were very, very valuable. And it's always the case that other people spot stuff you don't spot. We did a code reading club this week, this Monday, and we were voting on what is the most important line. So I voted on one of the libraries that was imported. And then someone said, no, but this library is only imported once. And then someone else said, no, it's imported twice. Look, it's imported there as well. So it's always that people focus on different things. Some people tend to focus very much on variable names. Other people tend to focus very much on the code structure. And all these things are valuable. So yeah, I think in general, reviewing as a group, but also ensemble programming, right? So this is like pair programming, but then with a bigger group. I think anything where you can benefit from multiple people with diverse backgrounds and prior knowledges, then that's very, very useful. Because you saw this in my talk, right? The more prior knowledge you have, you really see something different. So if there are 5 different people, then they will all see different things. And this is very likely to be not all the same spot. They will all see different things on the code, so you get a better view as a group.
Yeah. I highly encourage the people I work with to do code reviews together sometimes, because yeah, it really elevates in my experience as well.
Yeah, I think that's very true.
All right, thank you for that answer. Next question comes from Renee. Do you have any recommendation to get rid of, quote, you can write ugly C code in any language syndrome? Most code I come across falls into this category. People are not embracing their language. Why is that?
Yeah, so I'm not sure if the question is why is that or how can you prevent it, but I'll answer both. Yeah. So why is, this is your long-term memory, right? This is your long-term memory trying to be helpful, and it's always trying to be helpful also if it's not helpful. So I used to be a C# programmer. I haven't programmed C# in literally a decade. If I am iterating over a loop in Python, very often I will still type for each. It just comes out of my fingers, because I also think it's better syntax than for in Python, because for is both with I and also looping over list elements. So it always, I type it, and that's because my long-term memory that has practiced so much C# just says for each, and I'm like, oh, oops. Right? And this is what happens. So knowing something, I have a whole chapter in my book about this as well. This is negative transfer. So you can have positive transfer. If you already know Dutch, for example, then learning German is easier. If you already know Java, then C# will be very much easier. That's positive transfer. But you also have negative transfer, which is like you already know something and it inhibits you to learn something else. Like when I moved to the UK, I had to bike on the other side of the road. Then your brain is just like, no, this is all wrong, because you suddenly have to do something that you've practiced so often to do in that situation, literally in the opposite way. So that is the reason, is that once you know something, it's very hard to unlearn something, because your long-term memory is trying to be helpful, even if it's not helpful. So what you can do to prevent that, yeah, deliberate practice. So what you can do, as I described with the flashcards, is you can really try to immerse yourself in the new programming language that you're learning by looking at a non-idiomatic version. In Python, this would be the code that I showed in refactored form, that's not so Pythonic. And on the other side, you put a list comprehension. But then again, if you switch languages, which I know some people do for various reasons, that they do Java on Tuesday and they do Python on Wednesday, yeah, that's just really hard. Like it is very hard to speak German outside and Dutch in your house, if that's your native language, then yeah, you're going to make mistakes and be confused a bit.
All right, thank you, Felienne. There is a big, beefy, upvoted question. It's so popular that people even sent me messages that I should read it out, so I'm going to go ahead with it. David asks, you have to fix an issue in a big, not yet known code base. What is the best start? Any advice on potential strategy?
Yeah, that's a great question. I mean, that is very, very hard. So again, clearly I'm going to pitch my book because it was lots of work to write it. So my book has many, many, many different strategies. There are many, many things we know that work really well. It depends a little bit on your prior knowledge. So do you have lots of knowledge of this programming language? Do you have lots of knowledge of the domain? Do you have lots of knowledge of the infrastructure and the whole ecosystem? So it depends a bit. But there are things you can do. For example, some exercises that I do regularly also in the code reading club is you can mechanically scan the code and take a pen, it's best done on paper, you write down all the variable names. So you don't really look at the code, you take a variable name, you put it on paper. And then you have all the variables. So you're not looking at the structure or anything, you're just going to read all the variable names and you see, okay, so what domain concepts are relevant here? Do I know the meaning of all these words? If there are domain words there that you don't know the meaning of, that is going to be your first step, because you really can't comprehend the code if you don't know all the words. So that's like step one. Then you're going to look at, from the variable names, do I know all the programming concepts that are being used? If there's something like a hash map or a list, or is there stuff that I don't know technically? You're going to look those up. Those are the first steps in making sure you have the right prior knowledge. So that's something you can do. Then if you're ready for like doing structural work, you go back to the code, and there's another exercise that I do where you print out all the code. You print out everything literally on paper, and then you're going to examine the structure by circling all the variables. So every variable you circle, and then you put a link between the variable and where it is used. And you take another color and you circle all functions, and you put arrows from the functions to where the functions are called. And then you look at that, and then you see the structure right there. So this is all, notice how none of this is running the code. So you sort of see the structure. And from the structure, you can also learn something. So maybe there's one entry point that you've now figured out that everything depends on. Or maybe there's one class with different subclasses. So that's then, it sort of gives you a beginning, like where am I going to read first? And then that's where you start and you iterate through the code. The exercise I showed on the slide is also very helpful, where you run the code with 2 or 3 example values, like let's take 0 or 100, or let's make a fake customer and see what happens. But also notice that, yeah, all of these are still hard work. Like I don't have a magic trick, like, oh, you just do this and then it's easy. This is hard work. But my book is really filled with exercises like this that will try to, yeah, I'm not saying make easier, but at least make more manageable and more concrete. Because what I will wrap it up here, but what I often do, which isn't a great strategy, you look at this code and you're like, oh dang, oh, this is so hard. But you don't do anything. You just sit there and you're like, oh, this person that wrote this code, oh, I pity myself for having to do this. And then you're not productive, right? So all of the strategies that I described in my book are very productive. So you can sit down, you can look at the variable names, you are doing something. And then all these tasks together will help you form a picture of the code, but it's still hard. It is a hard thing to do.
Yeah, it's really interesting, right, that during university they encourage you a lot to use analog tools to look at programs, and we kind of forget this throughout the way in our industry career.
Yeah.
All right. Maybe one more quick administrative question. Where's your YouTube channel? Where can you on YouTube?
Yeah, I don't have a YouTube channel because I'm a bit old-fashioned, but I have the podcast. So you can listen to, if you like my analysis of software and software engineering problems, then our weekly podcast, Software Engineering Radio, is definitely a place to check out. And I am on Twitter. So if you want to have all my hot takes and gifs and updates about what I'm doing, then Twitter is also a really good place to follow me.
That's awesome. All right. I think we're ready to wrap up then. Thank you so much, Felienne, for this amazing talk.